thank you all for being here. Happy to answer questions. What we'll do is, I think Richard and myself will go through our material and then we'll have a Q&A session at the end combined. So I'm here to talk about the Pure Power engine and the good progress we're making. And since we'll talk a little bit about the market, talk a little bit about the benefits and where we are in performance, and we'll talk about our execution, how we're doing with the product, and where we are in our development and certification process. So first of all, we're on 5 aircraft. We're really proud of that. We're proud to be selected across these different aircraft. It's a big vote of confidence from our airframe customers to select us to put these on, on all these aircraft. This is a big step forward, and we look forward to being in the single aisle and regional market for many, many years. So we're really proud of the fact that we're partners with these airframe OEMs. Just to characterize where we are with respect to our engines and the different platforms that are out there, we have 3 different sizes of engines. Essentially, we cover 15,000 pounds of thrust up to 33,000 pounds of thrust. That provides power for aircraft in the 70 to about 185 dual-class seats. So to put it in perspective, we're covering that with 3 different engine sizes. 56-inch fan, which is covering the 15 and 17,000 pound thrust ratings. The 73-inch fan provides power in the 19,000 up to about 24,000 pounds of thrust. And then stepping up into clearly the single aisle market is more the 24 to 33,000 pound thrust class. Each of them is optimized for that particular market. The way we do that is we scale our design. So we're talking about an engine that's designed very consistently, and what we can do is actually scale the core and fan size accordingly to be optimal for the particular market that we're trying to serve. And we do that collaboratively with the airframe manufacturer. The program's going exceptionally well. Obviously we're along for the ride. We don't sell direct to customers. We are part of an airframe. So in order for us to do well, our airframe people are selling aircraft need to do well. And the good news for us is that they've been doing very well. The Pure Power engine has helped. 5,300 orders to date, orders and commitments to date. It's about 50 different customers up there. So that's a very, very rapid rate of sales for any new program. And you'll see, the spectrum of customers ranging from low-cost carriers to lessors to, legacy carriers. I mean, it's a really good distribution of types of businesses, and some are new. I mean, so some are capitalizing on the new capabilities offered by the new aircraft. Routes that were too thin to be served by a particular, or too long to be served by certain aircraft that for today's market are now being able to be served by these new aircraft. And furthermore, I mean, just regional distribution. We have representation across every part of the world. So, pleased with this. The engine itself, I mean, the reason why we're doing well, and the reason why we're able to participate on these different aircraft platforms is the fact that the engine itself is, we've heard the term a game changer. It's certainly a significant difference relative to today's engines. Look at the fuel burn, we're talking about 15% or more fuel burn reduction. And we'll talk about in the next slide why that is. Along for the ride, when you reduce fuel burn, you reduce CO2. I mean, it's just, they go 1 for 1 essentially. Actually, it's a different ratio depending on the pounds per fuel burn, but essentially it's a, percentage-wise, it's a 1 for 1. Noise comes down significantly. What we're doing with this engine is, the bypass ratio comes up, we move a lot more air. So as we move more air to create thrust, the velocity of the air can actually come down. So the noise comes down significantly. We're talking about a 75% reduction in footprint that you'll see at airports. So that means far fewer people are going to hear these aircraft take off. We expect that to have potential advantages with regards to curfews, when aircraft come in and come out, how early in the morning or how late at night they can come in for landings, and potentially route changes. So they'll be able to adjust their, instead of having certain routes that when they climb out, take them over away from overpopulated areas, maybe they can fly over because the noise is so low. So those are things that are happening. We'll talk a little bit more about the fewer stages in the engine. That's due to the geared architecture, the way we designed the engine. And NOx, I mean, our Talon combustor, the combustor that we have in there, so the third generation combustor. It's an amazing design, and it has 35% margin to the most stringent NOx standard that's out there now. So it's a fantastic design. So, I mean, all those things together, I mean, this is, again, why are people interested in this product? It's a combination of things, but you notice that things are going in the right direction. This wasn't a big trade-off type of engine where we improved fuel burn at the cost at significantly more part count. We didn't have to do that with this engine. So there she is, beautiful engine. For those who aren't familiar with engines, that's just a cutaway of it. You look at the fan on the far left and the turbine on the far right. And the key feature, which we always talk about, is the gear. It sits right behind the fan, and that's this piece here. So most engines don't have that feature. And what it does for us is allow us to optimize this fan to spin slower and allows this turbine and this compressor to spin faster. It's that simple. What we do is grow the fan out. That would typically force us to slow down these components. We don't have that constraint with this design. We're able to actually grow the fan out and maintain relatively high speeds on these two components, which allows us to maintain their efficiency levels. We don't have to trade off one efficiency for another. We can optimize the fan and simultaneously optimize the rest of the engine. So it's a pretty simple thing. It's got 7 moving parts. None of them are life limited. It doesn't really add significantly to the maintenance cost of the engine, but it does help us get rid of a whole bunch of parts. We removed about 4 stages from our low pressure turbine in the back, and we were able to remove about 2 stages from our high pressure compressor in the front as a result of this change. So that gets rid of about 6 stages and about 2,000 airflows. So that architectural change helped our efficiency. It also helped remove parts. And that's the fundamental reason why this engine is kind of a step ahead. Now, as you do some of those changes, you get the fan larger, we get better performance from the engine. This turbine spinning faster helps us burn less fuel, helps us reduce parts. So these all going in the right direction to help the overall economics for the airline operators. The people who are going to fly these engines are going to truly enjoy them. Now, a little bit of history. If we go back, this isn't something we cooked up over the past 2 years. This is something that goes back quite some time. 25 years. We started with an advanced duct propulsor. It actually had a variable pitch mechanism on the fan and was a ground test engine. Essentially, it was kind of a first put at a geared turbofan. And in fact, prior to this, we actually had an open rotor test. I mean, people have heard about open rotors, and fundamentally, our challenge at that time was the installation of an open rotor is difficult, and the acoustic signatures of an open rotor get to be a little challenging as well. So we went with a ducted nacelle around the engine as we see with most engines today. This was the first put. It worked. It worked well. It demonstrated the fuel performance that we wanted to see, but it was really heavy. We went and designed a flight weight gear system. That took a fair amount of time to get a flight weight design. We tested that in 11,000 pound thrust advanced technology fan integrated test. It demonstrated that this flight weight design gave us performance similar to this engine. So we got the performance we want, we got a flight weight, we got in the right direction. We moved on to doing a gear test rig. This was all about durability and reliability of the gear system. So we got the reliability, the durability, the weight we wanted, and the performance we wanted out of the system. The next thing was pull it all together. In 2007, 2008, we started doing full-up demonstrator tests on our ground tests. We ran on our 747 and we ran on a customer 8040. So those were all the things that happened. Now at that point in time, 2007, 2008, Mitsubishi and Bombardier were making selections for their new aircraft, and that's when they started selecting the GTF based on some of those results. Following those selections, we had launched at that point. Now it's all a matter of execution. It was all a matter of taking everything that we had done, the 25 years of technology investment, and turning it into a great product that was going to be reliable and meet all the commitments that we had promised. So we worked on core development, and we started doing the testing. So the first engine to test, FETT, for the 1500G back in October 2010, 1200G, and followed by the 1100G that's going to be on the Neo. So this is basically C-Series, MRJ, and the Neo engine, which led up to, a couple years later, C-Series certification. So again, it's going quickly and it's going well. We moved right through certification. The nice thing about the development program that we had, we learned a lot during the demo engines, several demo engines, 3 of them. What we learned through those allowed us to streamline right through these development programs. On the bottom, you'll see we also did flight testing of all these engines so far. We flight tested every one on our own flying test bed. And we actually have a new facility just outside of Montreal, in Mirabel, that's actually doing the production of our C-Series engines. That's a I think it's a 300,000 square foot floor space facility, brand new construction. Front side's assembly, back side is our flight test operations with our 2 747s. So very modern facility, state of the art. So obviously at this point you can kind of get a feel for United Technologies. Pratt & Whitney's making significant investment in facilities, ramping up production, and obviously in testing. So following, I didn't put it on here, I should have perhaps, was first flight of the C-Series, which came September of last year. So exciting times. So just to get a feel for where we are, I think there's a perhaps overlooked element to what we're doing right now. Typical development program for a commercial product would be 8 engines, up to 32,000 hours and 7,000 cycles. That's fairly typical for an engine development program through to certification. And what we've done right now is we've already achieved, we have 41 engines that we've made so far. We've got over 8,000 hours, we've got 18,000 cycles. And what I mentioned before about the common design, kind of a scale design, as we see things in any of these, we can apply them across products. So this isn't, kind of 2 dissimilar engines we just have to be testing at the same time. It's benefits of commonality, benefits of scale, and that's what we're able to apply to this design. So current activity, obviously C-Series engine is certified. I focus this on the regional market. C-Series kind of spans a little bit of mainline down to regional. C-Series engine certified. Flight testing is, as you know, we've already been briefing earlier today, very active right now. So Rob Dewar gave his update. We've provided our engines on the first 5 CS-100s. So all 5 aircraft have engines mounted to them. And these first CS-300 engines have been delivered as well. So, our Mirabel facility, production and assembly test facility, is putting out engines and very busy there. The MRJ, obviously the engine is undergoing testing for certification purposes. And, from their update, obviously the structural test is, aircraft test is going to be starting soon, flight test will be starting soon. Our engines for flight test are actually assembly now, and I don't have an exact date, but they'll be delivered shortly. They're going to come out soon. And the Embraer engines, we're in the final design phase, basically, with our partners there. So, essentially, it was kind of a quick race through, maybe perhaps, but I think you get a feel for it. I mean, right now we're embraced by our customers, at least that's how I feel. Airframe activity is good. We've done well in the marketplace. We've got over 50 customers and 5,300 orders. Origin commitments. We feel that we're the technology leader. The architecture change we've introduced with the engine has certainly made a huge difference in positioning this product. Its benefits are something that we've tested and we've realized. We see the noise benefit that we claim. We've seen the fuel benefit that we claim. We have confidence that we're going to meet our commitments and deliver our products on time and on performance to our airframe customers. Highest program maturity, we talked about the testing that we did prior to development and launch of the program. We talked about the fact that we've done considerable testing as part of certification. We still have more testing underway. I mean, just as an example, there'll be more endurance engine testing that we run as part of our test programs after certification. That's normal. And then meeting commitments. I mean, we've been along the way, we realign our schedule as necessary, but the commitments we've been keeping throughout the program. When engines need to be on dock, they're on dock. And performance-wise, we see ourselves meeting commitments there as well. That's it. Richard?